I'm Elias de Coninck. I'm the Senior Engineer of the Senior Robotics Engineer of Tractonomy Robotics, and we're based in Belgium, in the city of Ghent. And we're actually designing and making AMR, an automotive mobile robot. We do that with a rather small team, so we are currently with 6 people. Keshav, which wasn't able to make it here because he's actually going to join Roscon in India. And Geert is our main machine designer. He's actually building the mechanical hardware of the robot. And then me designing the software using Zenoh and all the middleware and ROS to build up. And then our newest member, Francisco, who's helping me with the software. So we are actually have already a couple of investors. One of them is the European Commission, some Flanders-based investors, and then also some VCs that we joined. We are part of the IMEC R-Start from Belgium. That's one of the biggest incubators in Belgium. So that's how we started the company in 2020, roughly, where we did some research project and started building up the robot. So first up, let me introduce our robot. We actually call him the Autonomous Towing Robot 2 because it's the second one we have. The first one was our prototype, and we just built up on top of that. This is a more industrial version of what the Conduct guys were talking about. This is pulling actually 600 to 700 kilograms with our base model, and up to, we believe, up to 2,000 kilograms with our newest and latest version. What we are doing is actually towing everything on wheels. So when you can attach a gripper to it and it has wheels, we can actually tow it. We have kind of different mechanism to support different carts. We use a rotating top plate and retractor arms to adapt to different carts. So it's not only a single cart application, we can adapt to specific carts, different widths, different calculations. And based on whatever we see from the robot, we adapt to that specific cart. Because we also have a new wheel, we designed this wheel ourselves. This is the omnidirectional wheel, also familiar from KUKA and other companies who already done it. But we use it as to optimize our movement and allow us to move in all directions with our base platform. Everything uses inductive charging. So we start by going to our base station, and then we just inductively charge just for safety because we don't have physical contacts. There's no sparking, there's no nothing. And we can actually also support in-road or in-road charging where the plates are actually mounted inside the road. So we can adapt and get bigger round trip times and all that to just get more users out of the robots. But we are not directly talking about our robot here. We are more talking about what is the framework that we are using and how we came to that approach and how we started using the Zenoh platform, or the Zenoh protocol, sorry. So the warehouse and logistics solution that we started building this in 2020, very early 2020, when ROS2 only started and was not very stable. So we envisioned a big architecture where we started from the robots running ROS2 and then going up in each layer of the network, going to the edge where we talk about getting all the data from the robot and not blasting the network with everything, then going into a management layer for the fleet that we actually direct robots to go to, that we have a warehouse management system, talking to the fleet, orchestrating tasks where they should go to, which carts to fetch, and then eventually where he needs to pick it up and drop it off. So the top layer is then once you get into the cloud environment where you have more predictive maintenance, anomaly detection, that you aggregate all the data of your entire fleet and then start making good assumptions about it, like saying, yeah, your wheel needs to be replaced because you've been driving it for 25 kilometers. So In the beginning of 2020, this was, of course, not when Zenoh was really there yet. So we were looking for a solution, and we started a research project with Fed for Fire and the European Commission, which was called the Robotics as a Service bench, which we benchmarked over ROS2. Because ROS2 was quite new at that time, I think we started with Crystal. So then it was not that stable, but we actually started a research project to see how well it would scale over a wide area network. So the project itself had a couple of ideas where we had multiple sites of customers, then multiple customers actually all talking over ROS2, in this case actually talking DDS, communication traffic, over even a VPN to different global enterprises and then different sites globally, talking to a cloud infrastructure that we had set up for ourselves. This was also it had also be deployed on a Fed for Fire system, which helped us actually scale these things. Fed for Fire has some test beds which are in the States, some in Europe, some in Asia, and then we can actually orchestrate deploying multiple sites, multiple customers, and actually scaling our virtual robots across these platforms. We developed the tool for it, which actually can orchestrate the setup with these test beds. And then we could quantify or set up some parameters, like, for example, do we use SROS, like the security level of ROS2? What quality of service settings do we apply on each subscriber and publisher? And then we can also throttle each link between sites, links between the VPN that we actually are going to throttle or introduce latency in the network and all these kind of things. Eventually, this tool never got released to the public because it got changed so much and the testbed itself is not fully free. And we found that in the end of the product, ROS was actually giving us quite some problems. Like a lot of presentations shown before me, in the beginning, ROS2 had issues with scaling. So during this project, we actually tried scaling from one robot, one virtual robot, to 200 robots, but we got already stuck at 40. And in that time, every robot, in our case, had roughly 10 nodes. If we would adapt this to our current robot, currently we have over 50 nodes for our single robot. So as in that state of ROS2, we wouldn't even be able to run our single robot connected to one of the other sites. Like, okay, our site was not local. It was running through a VPN over to a European center. I think it was located in Spain. So there was some distance, but we found out that even just the local Wi-Fi network was causing a lot of issues. What we did with this tool is actually test different RMWs. Initially, when we were using dashing during this report itself, the default version was FastDDS. And we saw that FastDDS was actually a lot worse in performance at that time than, for example, Cyclone. Cyclone would scale a lot better with more nodes. The discovery process was working a lot better. But still, we were hitting limits like once you reach 40, 50, 60 nodes. Then again, what is also very important for us is the latency of these messages. If you want to control your robot to teleoperation, you don't want to have a latency of 200 milliseconds. Or if it's really that it's a consistent 200 milliseconds, you can handle it. But as you see on the right bottom picture, it's actually fluctuating very a lot between different runs. So it was not consistent and we could not make it work. So it was not the end of Tractonomy, of course, but because we are still here. So we started looking for a solution. And that's also when we came across some nice guys from ZettaScale currently. But we first started adapting a bit of ROS2 because in 2020, there was no not really anything from Zenoh yet as to the public. So we started by limiting the ROS2 traffic based on domain IDs, or even literally saying that you were losing the local host network adapter. That was providing us with reducing the number of ROS nodes which were actually published over the network, but we would still see that once you scale up to 20, 30 robots, you have the same problems. So eventually the solution actually was Zenoh. We started using the Zenoh DDS Bridge early or mid 2021, I believe. So it was a very early version of it. Bleeding edge. Yes, we were even using the master version of it. So we didn't even see the tagged versions yet. But at that time, we could already operate just the default stuff. Just pops up like the topic, subscribing to it, see information, and we started using it for getting heartbeat messages to our infrastructure, seeing where the position of our robots are, and all those kind of things. So we started including a Zenoh router or Zenoh client with the Zenoh DDS bridge into each robot. So eventually the goal was to adapt that early architecture that we designed into this concept. And we actually exploded the use of it by including multiple Zenoh routers in each site of a customer. And then for each customer, they would aggregate these sites and then have multiple customers. So we aggregate those again. And then you have in our cloud also a Zenoh router, which connects directly to the robots. And we can route everything to Zenoh. What helped a lot by using Zenoh here is the plugins. Because we can actually scale and adapt our own knowledge of Zenoh stepwise. We first starting adapting our robots themselves. It was just plug and play. Everything worked out of the box. And then now that we can think of improving the performance once we go to the cloud, we can start removing ROS plugins on the cloud side to the Zenoh API. That would help performance, and then we could actually also use a lot more of the wildcard support of Zenoh instead of all relying on the ROS2 specific knowledge. So this helps us in a good way because now you can actually also monitor each robot individually from anywhere in the world if you connect to our cloud infrastructure directly to the Zenoh router running in the cloud. But we can still, if you have access to the subnet, directly connect to the robot if you want to have more access to it. So we split up our access based on scoping. So instead of using different ROS domains, we scope actually the Zenoh DDS bridge. And that way we can limit also which topics and which actions and services we supply to the public, helping, for example, customers who don't want their data to be public or transferred to a cloud. So here is a small demo of the current design of a robot and how he's working. So this is a very short demo, of course. This is running at a customer of ours. It's just adapting to the cart. The retractor's arm comes out, and he's seeing the tag, and then he's going closer. We already did a lot of improvements on this system. It's, of course, a work in progress. We've been working on this currently for 3 years. We're almost hitting the 4th year, but we will be starting adapting to more of Zenoh because we see that it's actually helping us quite a lot. So I hope you enjoyed my presentation. My name was Elias de Coninck, and I'm actually very glad to be here.
Thank you, Elias.